Have you ever come across a nuclear power plant? Well, one of the things that instantly catches your eye is the enormous cooling towers which dominate the landscape. And that's exactly what we'll be discussing today in today's video. How these massive structures work with minimal energy demand and why the smoke coming out of them is actually pretty harmless. And the reason behind that distinctive shape, making them so recognizable. Guys, welcome to another episode of Tech Dynamics. I'm Thomas, and today we're discussing cooling towers. Cooling towers, or more specifically, natural draft cooling towers, are an essential part of most nuclear power plants. A nuclear power plant is a type of thermal power plant which generates electricity through heat by transferring thermal energy from a nuclear source such as uranium or plutonium to a working fluid, most commonly water. And it's this water which, after being heated, pressurized and converted to steam, passes through a series of blades in a steam turbine. Upon exiting the turbine, steam needs to be cooled back to water to begin the cycle once again. To cool back the water, power plants use a condenser to extract the thermal energy from the water exiting the turbine. And it's this condenser that needs a cooling tower. You see, a condenser's job is to transfer the heat from the working fluid to the cooling water, which circulates from the condenser to the cooling tower and back. The cooling tower is there to lower the temperature of the water using natural draft, hence the term natural draft cooling towers. So, how do they work? Well, you see, the cooling water enters the tower through a series of pipes and is transferred to a manifold containing hundreds of nozzles which spray the water evenly onto a fill. Now, the fill is a form of mesh intended to increase the surface area in contact with the incoming water, acting as a large heat exchanger, lowering the temperature of the water, and while water flows downwards, cool air entering through these openings is channeled upward, creating a counterflow. This flow enhances the efficiency of heat transfer of the system. As the cool air and warm water come in contact, heat is transferred from the water to the air. So now the warmer, more humid air rises up the tower, which makes way for cooler, drier air to take its place, creating a convection current. Water molecules from the cooling water mix and exit the tower with the warm air, creating that white smoke plume we see. So no, that smoke isn't dangerous at all. The shape of the cooling tower, which mathematicians call a hyperboloid, helps increase the flow of air and water up the tower. The narrowing at the center of the tower increases the pressure of the air, accelerating as it passes through that restriction. And the widening back of the tower at the top mixes the outcoming air with the ambient surrounding air. Additionally, the hyperboloid structure gives both financial and structural benefits. Because of the height difference between the base and the top of the tower required to achieve an efficient natural draft and convection current, this shape is ideal because of the stiffness of the structure, far greater than cylindrical or rectangular structures. And this is just one method engineers use for cooling a working fluid. There are countless other methods engineers use to manipulate the temperature of fluids, depending on a number of factors, such as cost, application, and the type of fluid we're dealing with. For example, a cooling tower in a high-rise building or hospital would use mechanical or forced drafts. And now you know a bit more about what goes on in these massive engineering structures. Guys, if you enjoyed this video, I highly recommend you watch this one next, where I talk about the billions of dollars tech companies are investing in nuclear energy. Don't forget to hit the subscribe button and let me know what you think in the comments below. And I'll see you all next week.